Okay, so here we were talking about how you can solve and then plug this into the calculator to get the value. You could also use the calculator by looking at the table and filling in the table and estimating where it's located. However, that's that's if you want to do that. So if we were to use the table, when I plug in 1.8, I would get 36.60. We would have 44.70, 54.60, 66.69, and 81.45. Okay. The other option with technology is to use your graphing tool. And if you were to graph, remember this would be your y1, this would be your y2, and you're going to look for their intersection. So when I graph the exponential, should look something like so. And then when I graph my constant, 60, it'll look something like this. This is my y-axis, my x-axis. And this again is my y2, my y1, and their intersection is the solution. So the intersection would come out to be 2.047, comma 60, because that's what you're looking for, right? So you have multiple ways of using technology to find your answer if you're on a calculator problem. Okay. Next, we have 2 log base 3 of 0.5x. Now, again, you want to make sure the log is by itself. So to get our log by itself, we're going to divide by 2 to cancel it out. And when I do one side, I have to do to the other. So now we have log base 3 equals 0.5x. Log base 3 of 0.5x equals 3/2. Okay. Now we want to get rid of the log of base 3. So get rid of the log of base 3 is to raise it to the power of 3. So I'm going to raise it. I'm going to raise. Sometimes I wonder if I'm saying that right. But the reason why we're doing this is that the log property says that a log and an exponential of the same base is cancel each other out. It equals 1. So we're left with 0.5 0.5x equals 3 to the 3/2. Okay. If you're using a calculator, there's no point of you trying to simplify that, rewrite it, leave it as 3 to 3/2. And then we're going to divide by 0.5. So now we know that x will equal, 2 times. The reason why I'm saying 2 is because dividing by 0.5 is divided by 1/2. When you divide by a fraction, you multiply by the reciprocal. So it becomes 2 times 3 to the 3/2 is my exact answer. And I'm going to plug it in the calculator to find my approximate. Okay. So, sorry. Go to Sylvie, turn it on. I'm going to type 2 times 3 to the 3 divided by 2. Hit enter, and I get that it's 10. We're going to say 10.392. So 10 and 392 thousandths. So we get 10 and 392 thousandths. That's our approximate value of our x. Okay. Again, same thing. You could track it on a table. So by tracking on a table, that means I'm plugging this function in and doing 8, 9, 10, or I'm plugging in the values for x, however you want to do it, but filling in those table values and guessing, approximating where it's at. But if you have a graphing calculator, like we said before, what option you choose to go by is up to you. But at 8, for 8, we would get 2 and 52 hundredths. 9, we have 2 and 74 hundredths. 10, we have 2 and 93 hundredths. 11, we have 3 and 110 or 10 hundredths. And we have 3 and 26 hundredths here. Now, so that lets us know that our solution is somewhere between 10 and 11, right? Lastly is graph. So graphically, what you would put in So your y1 would be your, either one, you can leave it as is, but your left side is your y1, your right side is your y2. You want to make sure that this is a constant, at least. I feel like it's guaranteeing what you're doing, that you know what you're doing. So I'm going to draw my little XY plane in. This time, it's a log function. So we're coming up. We're going, right? There's my log. And then I'm coming from 3, and I'm looking for when oh, that's not a constant at all, guys. Can't even pretend. Can't even pretend that it's a constant. And it's going to go, meow, 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 meow. It keeps going, right? The constant goes forever. Again, y-axis, x-axis, and this is what my y1 would make, and this is what my y2 would make, and this would be their intersection. Their intersection would be at 10 and 392 tenths, comma 3. So it would be at about 10.39, comma 3. Okay? Again, as long as your y2 is already a constant, there's no need to divide. So you can just put y1 in as it is. Okay? Yeah. So technology. Now, here it says we're going to solve algebraically and then check ourselves graphically. So when you have problems like this, you're going to be using all of your algebra skills that you have, or you know, and that's going to involve you having to recognize some patterns and analyzing. So I have 3 to the x minus 3 to the negative x divided by 2 equals 5. The first thing I want to do is try to isolate my variables. So to isolate my variables, I'm going to multiply both sides by 2. So now we're working with 3 to the x minus 3 to the negative x equals 10. Okay? So 3 to the negative x means that I have, it can be rewritten as 3 to the x minus 1 over 3 to the x equals 10. All right? This is where using u substitution comes in handy. So I can use u, so I'm working with just a single variable, no variable and a power, and let that substitute in for 3 to the x. So everywhere there's a 3 to the x, I'm going to substitute in u. Okay, so I'm going to substitute u and u. So we're going to have u minus 1 over u equals 10. Now, we've learned before that in order for us to add and subtract fractions, they must have a common denominator. We also can use the chopstick method to quickly do this. So chopstick method is we multiply left to right, top to bottom, minus bottom to left to right, bottom to top, and all in the bowl. So here's a chopstick. First chopstick, u times u is u squared minus our rice. Second chopstick, 1 times 1 is 1, all over our bowl, which is u, equals 10. Okay, so that's a quick way to combine so that you now are working with one single fraction. All right, after you've done that, now you're looking at what you have. Well, I have a power of 2, so it doesn't tell me that I'm probably going to be a quadratic. You know you can't solve a variable when it's in the denominator, so you got to work your way of getting it out of the denominator. So I need to get this out of the denominator. So I'm going to multiply both sides by u. And so now what I'm left with, I'm going to move up here. I'm left with u squared minus 1 equals 10u. Oh no, I have a quadratic. How do I solve that? Well, in order to solve a quadratic, one side has to equal 0, and then you can solve the quadratic using factoring or quadratic formula. Okay, so I'm going to rearrange this. So this is going to become u squared minus 10u minus 1 equals 0. Now, there's nothing that multiplies to give me -1, but adds to give me -10. So I can't factor. So that leads me to doing the quadratic formula. So for quadratic formula, recall that it's your A, your B, and your C coefficients and constant. And then it's going to be your x equals -b plus or minus the square root of b squared minus 4ac divided by 2a. Hey, but in this case, we're solving for u. So u equals -b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so we're going to keep simplifying this, and we get 10 plus or minus square root of 100 plus 4 all over 2. That's going to equal 10 plus or minus the square root of 104 all over 2. Okay, 104 can't be simplified any more than that. 104, it's just, well, it could. Can we go there 4 times? 4? Yeah, we can reduce that. I lied to you. We can reduce 104. But honestly, there's no need to. But we can definitely reduce it. So let's just practicing reducing. When you are simplifying a radical, you're asking yourself, are there any perfect squares in here that I can take the square root of? And so, for example, 4 is a perfect square that equally divides into 104. So 4 divided to 104 is going to give us 26, right? Gives us 26. 26, however, does not have, it's 2 and 13. So it's made up of 2 primes. So 26 can't break down, but 104 can. So 104, the square root of 104 means I'm taking the square root of 4 and the square root of 26. Well, the square root of 4 is 2. Square root of 26 is just going to stay 26 because it's 2 and 13. All over 2. So I can simplify again. That's going to give me 5 plus or minus the square root of 26. So that is what it all comes down to. All right. Now, plus or minus means you have 2 solutions. One is positive, one is being added, one is being subtracted. So keeping that in mind. So our u can equal either 5 plus the square root of 26, or u in theory can equal 5 minus the square root of 26. Well, 5 minus the square root of 26 is going to be a negative. So you cannot equal that, okay? And the reason being is that our exponential cannot equal a negative value. So we know that it's not, we can't use this as for our u, but we can use 5 plus the square root of 26 for u. Okay, so we now know that this is what u equals. Because we know what u equals, we now can set it equal and solve. Okay, so we have 5 plus the square root of 26. Oh, that got ugly. Let's erase that. Square root of 26 equals 3 to the x. All right, so if I'm left with this as my thing, 3 to the x, I'm going to take, to free the x, I'm going to take the log base 3 of both sides. So log base 3 of 5 plus the square root of 26 equals x. That's our exact value. So this is our exact value. Pew, pew, pew. To find the approximate value, we're going to plug that into the handy dandy calculator. So calculator, screen, taskbar. And I'm going to go math, arrow up twice to log base. Also, I think I can fix some of your calculator so you have that feature on it. If you have the older calculator, we just need to update your OS. So we can try that out in tutorials. Plus second square root 26. Oh, I didn't even put that. Hit enter, and we get 2 and 2.105. So approximately, x is 2.105. Now, that's our approximate, that's our exact. So we are capable of doing this with and without a calculator. Now, if I'm given the calculator, if this is a calculator option, and it's not asking me to explain algebraically, then I'm going to go y equals. I'm not going to lie to you. I'm going to go to y equals. I'm going to put in 3 to the x minus 3 minus 3 to the negative x and it's going to be equal to 10. So this right here is my y1 and my y2. I'm going to press graph, and I'm going to see what I can see. You know, Sylvie, she graphs a little slow. She comes though. She's coming. Give her time. Now, notice that my range isn't high enough for me to see my values. So I'm going to need to change the range of my graph to see exactly where it intersects, but you can kind of see. So I'm going to change my range by clicking window. And we're going to boost it up from 10. It doesn't really matter how high I go, but I'm going to go ahead and jump as high as 20. I went on the X. You saw nothing. You saw nothing. Let me stop graphing. Go to Y equals. I said range, and I clearly did not change the range of my graph. I'm only going to be 15 now, but you know what I meant. Okay. Sylvie, she's a little slow again at graphing, but don't worry, my girl will get it done. There's the Y1. And slowly but surely is coming in my Y2. There's my Y2. And I need to find their intersection. So remember pressing second, trace, 5 for intersect. And it's like, is this the graph you want? Yes. Is this the graph you want? Yes. Do you really want to find their answer? Yes. And bam, did we get the same answer that we got? We did. Okay. So again, if it's a calculator problem, do the calculator. If it's a problem that's asking you to show the work or analyze the work, just do the work, guys. It's okay. It's all right to do a little bit of math. All right. Okay.